Okay, so our last video was looking at the molar solubility of silver chloride, which we determined by using a KSP value of 1.0 times 10 to the minus 10. This is not the actual KSP at 25 degrees Celsius. We just chose the number as it was an easier number to work with. So from the calculation in black there, you can see that the molar solubility turns out to be 1.0 times 10 to the minus 5 molar. And the other video shows how we calculated that. This video is more about actually increasing or decreasing the solubility of a salt. And so we're going to use silver chloride again and look at its solubility in three different scenarios. So the first being in water, the second being in 1 molar silver nitrate solution, and the other being in 1 molar potassium bromide solution. So let's have 3 beakers here, each of which has silver chloride added to it, and we know that silver chloride is low solubility compound, and so if we add it to water in beaker A, we should get a fairly good layer of precipitate forming pretty quickly. And then the question is, what would happen if we added the silver chloride to 2 other beakers, the second one being silver nitrate, and then the third beaker being potassium bromide. So example A, if we just add silver chloride to water, the salt would dissociate, and it would really not dissolve very much, because we know from the calculation above that its molar solubility is 1.0 times 10 to the minus 5. So really for question A, or for example A, the molar solubility is 1.0 times 10 to the minus 5 moles per liter, and that's all we would be able to dissolve in there. Now in example B, if we think about the silver chloride being added to a solution that contains silver nitrate, then the solution already would have silver ions in it. So what effect would that have? Now I'm going to show an ice table for this. We're not expecting you to calculate this out, but just to show you the math behind this. So let's say the initial concentration of the silver ions would be 1.0 molar before we even add any silver chloride. And then the concentration of the chloride would initially be 0. That is before any of the silver chloride dissociated. Now, as the silver chloride dissociates, there's going to be an increase in the amount of silver ions and an equal increase in the amount of chloride ions. So we would have 1.0 plus x at the bottom here, and then x over here. So using our formula here, we would get 1 plus x multiplied by x equals 1.0 times 10 to the minus 10. Now if we do a little bit of calculation on this, we're going to get a quadratic x squared plus x minus 1.0 times 10 to the minus 10. And if we solve that using the quadratic formula, we get 2 roots, and the root that's actually of interest to us is an x value of 1.0 times 10 to the minus 10. Now this x is the amount of chloride ions that have formed, so you can see that from right there. But it's actually the amount of silver chloride that actually dissociated into the water, because the chloride ions that formed would have come from the silver chloride that dissociated. So this actually means that the molar solubility of silver chloride in this beaker would only be 1.0 times 10 to the minus 10 molar. So that's the molar solubility of silver chloride in beaker B. And so that's obviously a decrease in the solubility. So that's a decrease in the solubility of silver chloride in that solution as opposed to the water, which you can see above was 1.0 times 10 to the minus 5. So that's a huge decrease in solubility. And that's because there were silver ions already present in the solution before we added the silver chloride. And so we call that a common ion effect. And so if you have a common ion compared to the salt you're putting in, that will decrease the solubility of that salt. Now if we take a look at, let's see, where we are, can I choose a different color here? Let me see, I'm going to go back to purple, change my font size. So in this beaker here now, it already had potassium bromide. And what we know about bromide, so this would produce potassium ions and bromide ions. We know that bromide ions have a low solubility, so bromide has a low solubility with silver. So as we throw in the silver chloride, it would start to dissociate, producing silver ions and chloride ions. But those silver ions would start to precipitate, so they would precipitate with the bromide. And we would get a new precipitate forming of silver bromide. So this is a new solid that would form. Now that actually would cause the concentration of silver ions to decrease. So what we would have happening is the concentration of the silver ions would start to go down as the new precipitate forms. So that would decrease the concentration, and that would cause the reaction to shift in the forward direction to make more ions. And that's from Le Chatelier. If you decrease the concentration of the silver, the reaction shifts to increase its concentration back up again. And so that actually would cause an increase in the solubility of silver chloride. So we can see that we can increase or decrease the solubility of a salt by having different ions in solution. In the next video, we'll address some of those questions.